Ladies and gentlemen, now we're going to go through the answers for problem number 5, where we are actually graphing a system of inequalities. So we're graphing two items on the same graph. So looking at problem A, we have a y-intercept of positive 1, and then we're going to go ahead and move a slope of 1 over 1. So 1 up and 1 to the right. It is a less than equal to, so it's a solid line, and less than means that we're shading below. We're now going to go ahead and graph the second one below the graph on the same axes. So we're going to go ahead and plot a -1 for our y-intercept, and then we're going to go up 2 and 3 to the right, and we're going to go ahead and put that line together. It is a greater than, so it is a dashed line, and greater than means above. Now, the area that you see in between here that is orange is our solution for this problem. So once again, anything on the solid line is a part of the solution, and anyone on the dashed line is not a part of the solution. Looking at our second one, we are going to go ahead and plot a y-intercept of 4, and we're going to move a slope of 1 up and 1 to the right. It's a greater than, so that's going to be a dashed line, and that's going to be shaded above. Looking at our second item down below, this is not a line, it's x squared, so it's a parabola. So first we're going to go ahead and factor it. You can do this doing the quadratic formula, or you can use a generic rectangle diamond problem, or you can do it mentally. As we're going ahead, we're seeing that we have a intercept and vertex for these different items, and we have an equation of x plus 3 times x minus 1, and that's going to give us our intercepts here of a positive 1 and a negative 3. In order to find the vertex, we're going to add these two together and divide by 2, or you can use negative b over 2a, and that's going to give us a x-intercept of our vertex of negative 1. We're then going to put negative 1 into this formula where we have 1 minus 2 minus 3, which gives us a negative 4 for our vertex. So as you can see over here on the right, this is how we found that out, looking for both our intercepts and our vertex. Now for A here, you're going to get 1 point for the slope of the line, 1 point for each y-intercept like we did on the last problem. You're going to get the point for each line for whether it's correctly dashed or solid, and 1 point for correctly shading on the right side. So that means, because there's two lines here, that you're going to get 8 points for problem A. Now for B here, for the line, it's going to be the same. You're going to get 1 point for your y-intercept and 1 point for your slope, 1 point for the dashed line, and 1 point for shading above. However, for the parabola, you get 1 point for a root of 1, 1 point for a root of negative 3, 1 point for your vertex, 1 point for the fact that you shaded with a solid line and you shaded on the outside. So B has 9 possible points in this situation.